Hey, welcome to the second video in section 6.5. In the last video, we talked about the inverse property for logarithms. In this video, we're going to talk about the product rule for logarithms, which will be one really nice rule that helps us simplify down logarithmic equations or combine logarithmic equations into a single logarithm. So we'll start with an example on trying to evaluate or get a handle on what the natural log of 432 is. And it turns out that 432 can be factored as 16 times 27. And we're going to show how to break this down into something a little bit simpler. The mathematics used is going to be a little bit tricky, but that's okay. Just pause the video when you get stuck and think about each step. But in the end, we'll actually end up with a really nice result. Okay. So the first thing we actually want to do is rewrite 16 and 27 with the base of the logarithm that we have. That is, we'll write it as e, and we'll say r equals 16. And we'll have e to the s equals 27. We don't know exactly what r and s are yet, except we're just going to say that they're the numbers that satisfy this equation. And from the inverse property, or even just our definition of logarithm, it's not too hard to see that r will be not log, but ln of 16, and that s will be ln of 27. This would be a good point to pause the video, replace r with ln of 16, and look at the inverse rule to see why ln of 16 is what r would have to be. Okay, but now that we know that e to the r is 16 and e to the s is 27, we can actually substitute e to the r in for 16 and e to the s in for 27 in our equation above. So we have ln of 432 equals ln of 16 times 27, which equals ln of e to the r times e to the s. All right, and now we have two exponentials with the same base multiplied together. Our properties of exponentials actually tell us that we get to add those together. We get to add the powers together. So we get ln of e to the r plus s. Now we're in great shape. Pause the video and see if you can figure out what the next step is going to be. Okay, so hopefully you noticed that we have an inverse rule type setup here. We have our natural log, we have our e. So our ln and our e will cancel out and leave us with just r plus s. And above, we had said that ln of r, or that r is ln of 16, and that s is ln of 27. So we can actually rewrite this as ln of 16 plus ln of 27. So what we've done is taken our logarithm and broken it down into a sum of two logarithms. So we have ln of 16 times 27 equals ln of 16 plus ln of 27. So we get this split. Now, at the moment, this isn't too helpful for us because we still don't know how to evaluate ln of 16 and ln of 27. But it does get us one step closer. We have a nicer number than 432 now, In practice, these will be easier to evaluate. Really, the best case scenario is when we can break it down even further, when we can potentially pull an e out of our number that's in there, or whatever the base of the logarithm is, and then evaluate some part of it. So we'll see an example soon. But first, we'll write down what our product rule is. So our product rule is that log of a of m times n is log of a of m plus log of a of n. So we get to split it up. Multiplication becomes addition. Now we'll look at a couple examples. So to just evaluate, let's say we want log base 2 of, let's do 48. So that's the same as log 2 of 16 times 3. And now we can apply our product rule. So we get log 2 of 16 plus log 2 of 3. And now log 2 of 16, that's the same as log 2 of 2 to the 4th plus log 2 of 3. And we apply our quotient rule, or sorry, not our quotient rule, our inverse rule. And we see that this simplifies down to 4 plus log 2 of 3. And so now we've taken a complicated log and we figured out that it's 4 plus a smaller log. And this can be great in applications on getting a handle on the approximate size of the number. So a common thing is to take a number like, we've broken it down to 4, and then log 2 of 3 is just a little bit bigger than 1. So we know that this number is probably somewhere around 5.2. Because we know log 2 of 2 is 1. So log 2 of 3 is a little bit bigger than 1. So this number might be like 5.2. All right, I hope this was instructive. The next rules we'll look at are the quotient rules and then the change of base formulas.